the funny face exhibit, which highlights the mathematics in the rest of the funhouse by showing the formulas that underlie the distortions that you see in the other exhibits. Let's take a look at how it works. Well, to get started, you hit the start button. And here you see an ordinary webcam. This works like any video photo booth. It's going to take my photo. I can hit the button here to take the photo, and there we have it. Not the most flattering photo, but that's okay, because what comes next is going to be even less flattering. Oh, look at that. Not the usual me. There's a formula down here at the bottom, which is distorting my image. And I can, of course, move my head left to right to change the distortion, or up and down. But I can also vary the formula. As I pull this slider across, the formula changes. And so I can see the effect that that formula has on my image. There's plenty of time for your visitors to play and find just the right picture they want to portray. There. How's that look? When you like it, just hit the button to take the photo, and you move on to another distortion. These work just the same. Your visitors get to take 3 distorted photos, and then you see them all displayed, each with the formula that shows the distortion that was made, showing the effect that mathematics can have on image processing. Welcome to Miles of Tiles, the exhibit where your visitors can explore the geometry of tessellations. This is one of our most open-ended and exploratory of exhibits, where your visitors can play on both sides and create patterns like the ones you see here that were created by visitors. The point is there's many shapes of tiles, but each one of these tiles tessellates, which means cover the planes in such a way that there are no gaps or overlaps. Here we are at the Roller Graphicoaster, the exhibit where your visitors can build and time their own roller coaster. This exhibit is actually based on a math problem that was posed by Galileo back at the beginning of the 17th century. It was too tough for him to solve and had to wait 75 years until the Bernoulli brothers invented a whole new branch of mathematics to find the exact solution to the Roller Graphicoaster problem. We've updated it to the modern world by casting in the form of a roller coaster design. You want to get your visitors from point A to point B as fast as possible for the biggest thrill. Let's take a look at how the exhibit works. Well, naturally enough, to begin, you have to go over here and hit Start. This is going to give several options of different roller coaster designs that they can try to use to get from start to end as fast as possible. Welcome to the Ring of Fire, the exhibit that lets you explore two-dimensional cross-sections of three-dimensional solids. This seemingly empty circle is actually filled with a plane of laser light. And that light illuminates anything that you place within it, making this exhibit very easy to use. Your visitors simply pick up any one of the translucent solids and place it into the light, lighting up the different cross-sections that you can get as you move it back and forth and rotate it to see the different shapes that lie within whichever shape they're holding. To guide their exploration, you can give your visitors several different challenges. The first is to try to find a rectangular cross-section within this cylinder. Even your youngest visitors will find that if you place it straight up, you can illuminate a rectangle. Another possibility is to look for the square inside this triangular pyramid, or, perhaps most interesting, to find the hexagon inside this cube. Here we are at the Organ Function Grinder. This exhibit takes the classic classroom example of a function machine and makes it real in an exciting and melodious way. Let's see how it works. To start, your visitors need to take an input ticket. Here's one, for example, that has the value x equals 4. Then you take the ticket to start off the computation, you put it into the machine where it says step 1, enter number. You stick it in with the barcode on top and in front, and there's a little diagram on the side of the machine that'll show your visitors how to do that. So let's put it in, and then the machine sucks it in. It's now ready to begin the function. Now you can set any steps you want. For example, we'll turn the first dial to double. Here on the second dial, let's try add 3. And on the final dial, let's see, how about extract square root? All right, now to actually make the function go, make the machine go, you just need to turn the crank. As you do, it'll start the function. Right now it's playing a song that corresponds to the input number that came in, and then it'll do each step. Right now it's doubling. Now it's going to add 3, and you may have heard that the tune changes with each step. For add 3, it raised the pitch of the music. And now we're extracting the square root. You can hear it's made the music richer by adding a voice. Now we're done with the function, and we're going to get our results out here at the other end. Here it is. It shows the original input value, x equals 4, the function we just computed, square root of 2x plus 3, and the output value. Here we are at the number line tightrope, where we've taken the black and white monotony of the traditional number line and brought it to you in Technicolor. What we've done to make the world of numbers come alive is add these icons to each of the numbers that show different properties that numbers can have, from the very familiar, such as the square numbers. 49 is 7 times 7, so it's the square of 7, to less familiar properties, like the prime numbers, which are indicated by these atoms, or the pizza numbers, which are indicated by these pizza slices. What's a pizza number, you say? You can find out in the number line tour guide, which we provided for you to distribute to your visitors so they can take their own tour along the wonderful world of numbers.